Good evening, everyone. Welcome. Welcome to the session. Yeah. Today we will talk about the transformations part, which we can do on Databricks. First of all, I have to create a cluster here. It will take some time. So I'll first create a cluster. Go to new, more clusters. Create compute. Okay. It's getting created. Meanwhile, we will discuss about the data transformations and how Databricks supports these data transformations. Yes, data transformations. Data transformations is a process of converting raw data that has been extracted from different data sources. It could be streaming data, batch data, log data, and we have different types of data formats, CSV, JSON, it could be sensor data. We have multiple sources and of course, different variety of data. And getting that raw data, and obviously data coming from multiple sources and in different varieties, it will be messy information and we cannot trust on this raw data, and that is why we need a clean quality trusted data, and we do that by applying some transformations. Sorry. Okay. We are talking about data transformations and the trusted data where you can extract some insights. And that's what data transformation. The raw data, which is not a usable one, you'll convert that into a data source that is more trusted and has a more business value and has a structure and where you can extract insights. There are different types of transformations, like dividing the data into bins, data aggregations, cleansing. The most common type of data transformations which we use is cleansing, data deduplication, and then data derivation. You derive new fields from the data or the new attributes. Data enrichment. By joining different data, you will enrich the data that is available. Like that, we have so many: filtering, joining, splitting, summarization, data validation, ensuring the quality, like this. Out of this, the most common data transformation we use as a data engineers or a data analyst is first you validate the data and then clean the data, and then depending upon the project you will do data enrichment or summarization, integration, derivation. But the basic kind of transformation is validate your data, clean your data. Today we will see these two types how we can do on Databricks. See, the Databricks which I am using is Community Edition Databricks. Here you can upload data into the data catalog. Just go to new and add or upload data. You can drag and drop the files from your local system, and I have already done that. In catalog, I have so many files. In Databricks file system, I'll take you there and you can see all these files are there. Out of them, I'm going to make use of this wind turbine data. And there are different versions of that data. I'll go to workspace. And here you can click on new and create a new notebook. I already have this notebook, so I'll open directly from here. The notebook, I'll go to recents rather. Wind turbine data process pipeline. This is a notebook where we will talk about the transformations. Now here, I'll take this 3-step architecture, also called as medallion architecture. In this architecture, you will segment your storage or your platform into 3 sections. It could be folders or schemas, anything. The schema or folder, you name it as bronze, and this one as silver, and this one as gold. This is called as medallion architecture, especially good for when you are getting data from multiple sources and in different data formats. It's better to first put your data in bronze layer in its raw format. For example, event data is coming. You can save all the event data in the bronze layer. Later you can analysis in .json format. No, you have a batch data you are extracting from the databases or sensor log files you're getting. Then save those txt files, log files as a txt files, or CSV files you extracted as CSV format. Here you can save your data in raw format in form of files. And then you can validate your data, whether it is right quality data or not. And on doing this validation, you will come to know the issues with your data and you will clean your data. After cleaning upon data, we will put it into the another folder or schema with the name silver. And here our data will be available in cleaned format. It is ready for analysis. It is not having any issues, like it's not giving messy information, no misinterpretation of data will happen. We are not in a space where we get false insights in silver layer. But still, we are expecting more data enrichment, or we want to apply some business rules, or you want to derive some additional columns. For example, the data is transactions data. You don't want sales to be less than 0. Even though it is cleaned, there are some miscellaneous values like that. You can apply business rules. Suppose this data is wind turbine data like ours. Adding a weather data will be helpful. So you can do data enrichment by adding third-party applications data like weather. Like this, you can derive columns, you can enrich your data, you can apply business rules and standardize your data, and then you put it in the gold layer. This is nothing but a folder or a schema structure which you can create. And finally, in the gold layer, the data is consumable one by your analytical applications. It's a gold standard data. And here you can save your data in a data warehouse in the form of tables because it's more structured. In bronze layer, you can save your data as it is as a file because it is a file system, it's raw data. And since Databricks has both, it offers you a platform to save your files as it is, as well as a data warehouse to create your tables. Now let us take an example of this data set called wind turbine. I am simulating some data. This is not a real-time data, simulated data. And with that simulated data, we will explore this medallion architecture as well as the transformations which you can do on Databricks. Okay, and coming to the runtime part, Databricks provides a compute cluster for you, fully managed. And using that compute cluster, you can apply your transformations in the language you want. It supports PySpark, most used language, especially coming to ETL, big data. PySpark is most common language which we use. Sometimes we use Python when data is coming is not very huge, it's not big data. Then you can use Python libraries and SQL. You are connecting to some database, data warehouse, you're extracting the data, you're querying directly from a database. Your data source is database. Then you have this SQL. You can also write your SQL code. And these are the options we have in Databricks. And we will use PySpark. Let us get into this notebook. And the first thing what I'm doing is I'm creating layers. Since I already have these layers, I didn't deleted them. I mean, with the same names, I created folders. So I'll just say bronze 04, silver 04, and then gold 04 layers. I'm creating them, making directory in Databricks file system. First, I have to connect the compute cluster. Right. Yeah, I have connected my cluster and I'm creating directories. Let us run this. See, bronze 04, silver 04, gold 04 directories. And they are created. And I am listing out them. See, this is the place where I have created. And %f meaning I am interacting with the Databricks file system. So I have to say %fs. Run this. Options you can see here. There are so many of them. And gold 04, silver 04, bronze 04 layer are there. So this is to check data in silver 2 layer. Right now I'm not running this. Now, before starting my Spark code, I have to initiate the Spark session. And this is the lines. These are the lines to initiate the Spark session. Done. And the first thing we have to do is get the data from the bronze layer. Since I don't have the data set right now, I'll use the bronze layer folder where I have uploaded the data earlier. From there, I am reading the data set called wind turbine data, new -1. Header true, info schema true. Meaning we are saying there is already column names, that is the first row, and info schema equal to true. We are asking Databricks or the PySpark running on the Databricks to get the schema on its own. That is column names and their data types. And then df.show5 displays the first 5 rows. And you can see those first 5 rows. This is the data. We have turbine ID, location, operator, turbine type, and finally some measurable values, allocated land hectares, permitted capacity, installed capacity, power output like this. And we will also print the schema. You can see the schema. And by observing the schema, I can identify, and observing the schema is first step of validation, validating your data. And you see the location can be string, operator can be string, but installation date, operating years, data timestamp cannot be a string. There is invalid data type. Zones can be string, land integer, and the developers, yes, the name of the developers is a string value, and other measurable values, integers. Okay, we found out that there is one invalid data type, which we have to fix. And we are checking for total number of rows and columns. That is a second step. The few steps we do for data validation. First, we have checked the schema. Now we are checking the size. Now what we are doing is validating our data. And we have 1006 rows and 15 columns. And now we are checking for missing values in each column. And this is the Spark functions which we are using. So I'm importing this column, COL, and sum functions. And there are inbuilt functions in PySpark like .isNull, which will give you true or false as a, right? It gives you true or false as the value. Now what I'm doing, df.select, I already read that CSV file into the data frame. Data frame is nothing but in-memory table. You can compare it like that. And df.select. And what are we selecting? Columns. And I am checking whether that particular column is null. If there is any null values, then it will be true. That means equivalent to 1. Boolean values. If it is null, if it's not a null, then we will get false, which is equivalent to 0. Now is null returns a Boolean value. Now that Boolean value we are casting, that is converting into integer. And from there, what we are doing, we are giving some alias name. And then for C and df.columns, for every column we are applying and summing up them. So for each column, we are checking the null values. If there are null values, is null will return 1. And all of those ones we are summing up, which gives us the total number of null values in each column. Let us run this. Now this is one more validation step, data validation. It is giving the output, but it is clumsy. So what I'm going to do, I'm going to arrange this clumsy format into a neat, visually appealing format and understandable format. For that, I'm doing the same operation. I'm calculating the nulls as I have done in the earlier cell. And then what I'm doing is I'm printing them by giving spaces. See, I have used this symbol and I am leaving 30 characters of space before this symbol and after 15 characters after printing. See, it has to print a column name and then 30 characters of space, and then it has to print the missing value total, right? Missing values.df collect. It collects from this data frame. After printing, there should be some 15 characters of space. And as a divider, I am printing hyphen 50 times. And when I run this is what I'll get. A table kind of a structure. And by looking at this, you can come to know there is another issue with your data, another inconsistency. Turbine ID, operator, turbine type, installation date, operating years, blade length, data timestamp, all these are missing values. Around six missing values are there. Now I'll just say df.describe show also to know about the statistics. See, these are the statistics. And df.describe, since it's not visually appealing, df.describe, I'm saying truncate equal to false, which will not cut down the column names. Anyway, it's not doing, but I'm saying truncate equal to false. That means don't chop down the lengthy column names. And then vertical equal to true. Instead of showing things horizontally, I want to, I'm arranging the things in a vertical view. Run it. And you can check it out now. See, turbine ID count, mean values. For strings, anyway, mean will be null. And for other fields, you can check the values here, mean values for measurable values. And then summary, standard deviation. See, minimum and maximum values for each field. So these are the things. And another thing we will do as a part of data validation is checking duplicates. And in PySpark, we have this function called drop duplicates, which will drop the duplicates when particular row is having all the fields exactly matching with some other row in the same data set. Such kind of rows you don't want, you can just apply drop duplicates. But now I'm just validating my data. So I want a count if there are any duplicates. I want to check that. So what we are doing here, we are not dropping the duplicates. Instead, anyway, drop duplicates will try to drop, it will fetch the duplicate rows. I'm just counting them and printing them. Let us run this. 0 duplicate rows. And distributed analysis, how data is distributed, like which values appeared most of the times, which turbine appeared most of the times, these kind of values, like temperature, what is the most common temperature coming from most of the wind turbines. I can just understand this data, I mean these type of things by observing distribution analysis. As a sample, I am just applying distribution analysis only to this column location. I just want to check the values within that location attribute or field, how those fields are distributed, meaning most common locations and count wise. See, almost these wind turbines, even though it's a synthetic data, they are arranged like an even distribution. And in wind farm 1, we have 202, and 5, we have 201. The wind turbines in each wind farm. Okay. Then what we are doing, we are identifying the categorical columns which are assumed as string type. I mean, we are trying to check what are categories, what are dimensions. Run it. Right. And also we are checking how many times these categorical values appeared in the data set. Like the turbine names, you can see it's only showing the top 10 rows. And then location. So overall distribution analysis of categorical data. And then correlation. Correlation is one more type of data validation we will do. Run this. And we are correlating wind type with power output. Is there any correlation between those two? Null. There is no correlation between these two columns. Like this, you can try and test with different combinations of columns where you feel they might be correlated with each other. And finally, we are displaying entire data set. And this display is Databricks function you may not find in regular PySpark. And this is the entire data set. And you can also observe the data types. There is icon over here, which tells the data type also. Now with this step, I have completed my data validation. And we found out that there are some missing values. And then there is missing values and also a invalid data type. Timestamp is actually available as string. That is one. And among with those things, if you observe here, total land hectares, allocated land hectares, we don't want spaces in the column. Certain kind of analysis like machine learning analysis platforms, they might throw error or they will not accept field names which are having spaces. So we will also rewrite these column names. We will edit the column names. We have to handle the missing value, that invalid data type, and also change the column names. Next, that is our cleaning. Or you can also call data preparation. Let us start data preparation. And this data preparation, we start with first replacing the spaces which we have observed in the column names, like installed capacity, power output. We will replace those spaces with underscore. Anyway, brackets can be there, but still we are replacing brackets with nothing. That means we are removing. And what we are doing, one more thing, we are also converting all the column names into lower case. And there we are using strip function, which will strip the column names, each column name. I mean, for example, we will take this column, installed capacity. See, installed capacity. First, we will convert into lowercase. Anyway, it's in lowercase, but we are ensuring that all the column names should be in lowercase. So this is also one type of cleansing we are doing, standardizing all the column names. After converting all the column names into lower, I mean each column name, we are applying this on each of the column. Right, further you see we have applied a for loop here. And now coming here, let us say installed, and something is there in the column name. We are stripping it into array of I, N, S, T, A, L, 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 comma L. And then finally we have a space there. Now from the strip, we are using replace, and from the list of characters, if there is a space, we are replacing it with underscore, and from that list of characters, if there is braces, we are removing them by providing null there. And then we are applying them one by one, df to df. That means we are converting, we are applying this to all the columns. See, and a clean column is a function, and we are running this in the for loop. We are calling that function in a for loop. And as a result of that, all of my columns will be in lowercase, and also there will not be any spaces and special characters. Then duplicate rows. Anyway, there is no duplicate rows, but still I'll just apply df.drop duplicates. If there are any, they will be dropped. I mean, exact row duplications. You can also apply duplicates to particular column, but in this scenario, it is not applicable. And then we are dropping duplicates in data timestamp, which we can do, but since it's a synthetic data, I have the same timestamp everywhere. I'm not going to do that. Otherwise, for time series data, you know that sensors will send values every second or every minute. If you suspect any data duplications because of some reason, even though you drop duplicate, you don't want the same location to be repeated, or you don't want to the same timestamp rather than saying location. As an example, you don't want same timestamp from the same sensor again. You know that the sensor has to send data for every minute only. Then you can select only that column and you can drop the duplicates. But I'm not applying this. I am going to lose the entire data set if I do that. So this is just for information. And checking the missing values again. The same thing which we have done in the data validation, that is the same piece of code. We are checking the missing values. We have fixed the column name, right? We have standardized the column names. We have removed the duplications. Of course, there are no duplications, but still we ensured that there are no duplications by applying drop duplicate function. Now, missing values. And here, I can apply different strategies to different type of data. Turbine ID is having missing value. I can say turbine ID is not applicable, or I can fill any custom value here. In that way, I can handle this missing value. Operator name also same thing, I can replace with a custom value. Turbine type, all the categorical values, you can give some custom value. Whereas measurable values like operating years, and then we have data timestamp is also missing, blade length is missing. We can figure out, can we fill in with mean or median values here? Operating years, can we give any mid value? Blade length, can we calculate any mean and give that? Or average, can we give that? We can try in that way, fixing those missing values. Let us see. No, you don't want to fill in your missing values. If you want to just drop the null values, you can apply df dot drop na. It will drop all the rows which are having missing values or null values. I'm not running this. We will look into different options we have. We will apply these options to handle these missing values. Option number one, you know that 50% of missing values are there in certain columns. You can figure out such columns and you can remove them. Right? Again, I'll run this, which will give you me the latest missing value data. No, it is same data. And then I am filling the null values. So dot fill NA, it is another function of PySpark. We are filling power output with 0 and location as unknown. It's just an example, guys. We have an option of calculating the mean or value for this, since it's a numerical value. Just for demo purpose, one way of filling the null values is replacing them with default values or custom values. Power output, I am replacing as 0 wherever missing is there, and location as unknown. Now I'll just go and check power output. Anyway, there is no missing values. And location also 0. Then why I am applying it will not do anything. But just in case, if you have null values there, you can apply this. And option 2, this is one way, filling the custom values. We are figuring out different ways of filling the null values. Option 2, filling missing values based on data type. Like you can calculate mean or median. Here we are importing the function called mean. And I have these columns, operating years and blade length. I'll calculate the mean, compute the mean, and fill missing values with mean. We will just go and check operating years, 6 missing values. And then another thing is blade length, 6 missing values. And here I'm creating a list with 2 elements, 2 columns, and applying a for loop on this list. What I am saying, I am df.select, select the column, and collect the first 2 elements. And where are we computing mean here? Here, the mean value we are computing. See mean, sorry guys, here mean we are calculating the mean of the each column. Right, when you collect, you will get array of 2 because you have 2, right? In each, you will get a mean value, column name and the mean value. You are getting the first element in the array in both the lists. And then let's run this. Now let us go and run the missing values cell again. Now you see blade length, we don't have any missing values. Operating years, we don't have any missing values. We have filled it with mean. If time series data, yes, we have data timestamp, and it is actually data timestamp should have to be date data type, but it is not. First we can convert and then we can apply, but it's okay. Even though it's string, we can apply window function. This is another way of filling missing values for especially time series data. Now what I'm doing here in the data timestamp, I'll just go and observe the missing values. Data timestamp 6 missing values. And then we have installation date 6 missing values. So what I'll do here, here actually we are not trying to fill in timestamp. This one, we are arranging the data set based on data timestamp, right? In first, based on timestamp, the entire data set will be arranged. What values comes first, next, based upon the timestamp we are ordering. By ordering in this way, you have observed that in installation date, there are missing values. And this installation date, I want to apply window function. For example, this in installation date, this particular cell is missing. So what I'm doing, applying a window function, and I'll check the date above this cell and I'll check the date below this cell, -1 and 1. And I'll select some date, either what I'm doing. I am saying rows between -1 and 1 and taking the last installation date, right? The previous installation date, this one. So we are fixing up a cell. -1 means earlier one, 1 means next one. Now installation date, when I say take last installation date, then it will take this one. And we are saying ignoring nulls because data timestamp also has null values. So when it is a null, then we are saying ignore the null over the window specification, this one. That is windowing. One more technique to handle the missing values. You can apply this data that is dependent on time, like time series data. Now I'll go and check out the number of missing values. Only it resolved one missing value. Maybe this installation date has missing values in the same place where the data timestamp is also having the missing values. That's okay. We have also discussed about the window technique and categorical missing values. We are giving the frequent value. This is one more type of handling the missing values. Whatever the value that frequently repeated in that column, especially operator and turbine type, we are just going with the frequent value, which is mode value. We are grouping the column name, counting it, and order that count. And that count gives, when you say ascending equal to false, whatever value is having the high count, you will take that and fill in the missing value. That is most frequently repeated value in that column. For operator and turbine type, we have chosen this method. Are these methods are valid? No, these are for demonstration purpose. You have to think, filling with most frequent value for turbine ID, is it okay? You have to figure out that. If you feel it's okay to fill in the most frequent value, you can do that. So now where we have applied operator and turbine type, you can see the operator 0, turbine type is 0. And we have missing values in data timestamp, installation date, turbine ID. So for these, what we will do, we will just drop them. Like that is the first method. Instead of applying first, now I don't want to fix them. Turbine IDs, right? You cannot fix the turbine ID missing value because it has to be, we cannot predict from which turbine it is coming. And also the data timestamp. So we try to handle most of the missing values. In the process, we discuss different ways of handling the missing values. Then I'll just say drop any function. And again, I'll check this. I'll run this cell. Now we don't have any missing values. With this step, we have completed our data validation and cleaning. We have one more data cleaning step. We have this data timestamp string, right? We have to convert that. We have to convert that. So we are using this two timestamp column and timestamp double type. These functions we are importing from the PySpark. Functions and types we are importing from the PySpark. And dot with column is function of the PySpark. When you want to alter the columns or if you want to create a new columns, dot with column can be used. See, it takes two arguments. First argument is your column name. I mean the new column name which you want to create, actually, not the column name, new column name. And you're creating a new column, then you will apply a condition or how you want to fetch the values for this new column. And here I'm not creating a new column. Actually, how the function work is, it will create a new column called data timestamp. And it is converting to timestamp data timestamp. So it checks that it is the same column name. It is not actually creating a new column. We are converting the data type to timestamp. And what format? Date, month, year, hour, minute. We are converting into this timestamp. When column names are same, dot with column function will alter the column. Now, instead of data timestamp, if you give some new timestamp, then it will create a new column with the same values but altered to the data timestamp. Timestamp data type. And we are also ensuring that all the timestamp should be in that data types only, time and date related columns. We are just ensuring that they have to be in this format only, timestamp. And then we are also converting power, permitted capacity, installed capacity to double data type. Earlier they were float. We are ensuring that it has to be double. And we are printing the schema, truncate equal to false. We know if you don't want your df.show, which will display the first 5 rows, because we gave 5. In that, column name should not be chopped down and vertical equal to true. It will show the data in vertical format rather than arranging them horizontally. Because we have 15 columns. And on the screen, those 15 columns are not fitting. So we are vertically arranging them. We made these changes, and you can observe those changes. First, the schema, data timestamp is timestamp now. Now with this, our data validation, data cleaning for this data step is done. However, we are also doing one more step. That is, we are extracting the data, month, year. We are separating the data from installation date. We are separating year, month, and also we are categorizing power category as low, medium, and high. And run. Right? And we will save the transform file to silver layer. I'll have created silver 04 layer. I'll make use of that. I'm saving there. Now here also I have saved as a CSV file, as a flat file only, but it is a cleaned file. It is not having those inconsistencies. Now I am reading that from the silver layer, and in gold layer, and finally our gold layer, I'll directly go there. There we are joining the data with the data called maintenance data. See that maintenance data is already available in this location. I'm saying spark.read, which reads data into the memory. And then display df maintenance displays the data. After that, we are showing the unique turbine IDs in both the data sets. See, unique turbine IDs. And then based upon the turbine ID, we are doing the left join. df.join. And this is the joined data. And we are ensuring that in the joined data also, timestamps should be of timestamps type, date should be of date type, and other numerical values should be of double type. Same like the earlier transformation, we are applying on the joined data set also. And then the joined data, now we consider it as a gold standard data. And what kind of thing we have done apart from cleaning here? Data enrichment. After doing data enrichment by joining with other data set maintenance data, we are writing the data as a table, where in the default database of Databricks. So when I'm writing tables, I'm saying delta. They are delta tables. If already this name is there, it will overwrite. I'll run this. See, finally, the transform data we are saving as table in gold layer. So here schema I can create as gold because it's a table. I'll create it under gold schema. Still, okay, it's done now. And also I'm saving it as a file in gold layer folder as a file as well as table. I'm checking the data from the table. See, you can. It appears as same, but it's not from the file we are reading it. It is from the table we are reading it. And we know Databricks is a data lakehouse platform. We started bronze layer as a raw data in flat file. And in gold layer, we saved the transformed data, enriched data as a table. Okay. Thank you.